Alright, we're back. We are back. Hello again. You can hear me? Mic check, audio check. Stream isn't loading for me. Is it working now? Should be. Okay. Stream isn't loading. Can you see the stream? Mic check. Hey, Karam, how are you? How are you? Alright. Video check. Are we good? Video check. Are we good? Video check, video check, video check, video check. We good? Okay, I can see it here. Hello, everyone. Welcome. Why did you say 5 by 5? Hey, what's 5 by 5? Social Neil is a 5 by 5. What do you mean by hey CS puppy 1 2 3? What do you mean by 5 by 5? Talk. Ah, okay. I thought you meant, I mean, when I hear 5 by 5, you ever, I would think about the weightlifting routine 5 by 5. Yeah, that's what when I hear 5 by 5, I mean, the weightlifting routine. Hello, everyone. The usual spiel. I'm Ming Chow, Associate Teaching Professor at Tufts. Introduction to Security, and today is the oldest trick in the book. SQL injection. Dumping databases. We're going to dump an election database. Fictitious one. Hey, Bot Ranger 24. Yes. Dump all the data off databases. This is generally speaking, the vulnerability why data breaches happen still in the year 2024. Now, before we begin, I'm just going to do a really quick exercise. We're going to come back to the damn vulnerable web application a little bit today. And, oh yes, let's go to SQLzoo.net. How many of you here is not comfortable with the structured query language? Okay. So, okay. Let's take it a step back. A database. A database is a collection of data. You've all heard the term database before. Okay. Now, databases can take many different forms now these days. There is something called NoSQL. It's just a place where you just dump unstructured data, whatever you want. That's MongoDB, Redis. But one of the most important databases in the world, like your bank database, student databases, is based on the idea of something called relational databases. Now, relational databases, the data is structured. There are columns of certain names, field names, and also certain data types as well. Okay? And there are rows. Rows are the records. So I'm doing this because I am not confident that many students know basic structured query language. In fact, it's not even required in our computer science curriculum. It's really sad. And this is a thing that is brought up in job interview practical applications. If you're going to be writing application, especially important web applications down the road, you got to know structured query language, or SQL, to perform queries, inserting data, deleting data, you name it. Now, the SQLzoo.net is a great tutorial on how you use a structured query language, SQL, and how you manipulate databases. Okay, let's go and do the first exercise, the select basics. And that's all we're going to need today. You got to know this. Okay, so here we go. Here we have a database table. The table is named world in lowercase. There it is. All right, hey Luffy. So world is the name of the database table. This database that is being used in SQL Zoo has many different data sets. One of them is world. And as you can see, the world database table has 1, 2, 3, 4, 5 columns. The name, the continent, the area, I think that's square foot, like footage or something, like square miles or something, the population, and the GDP. The gross domestic product, area, and population. As you know, as you can see, the area, population, and gross domestic product are all integers, they're numbers. Okay? Now, one thing about relational database, you can't mix strings in a field that is numbers based. So you have a string inside a population, that makes no damn sense. Okay. Now, let's do an example. And here, let's talk about the select statement. The select statement is querying data. Okay. Now, the general form of a select statement looks like the following. Now, it is select followed by the list of fields. Now, I'll just write it down. Select fields from table, and this is optional, where conditions. Okay, so a general structure of a select statement in SQL to query data from a database table looks like the following. It's select, followed by the field names, followed by the from, followed by the table name, and then optional is conditional, where conditions. A couple of really fine points. In this case, select, from, and where are SQL keywords. That's number one. Number two, it's also very important to know that by convention, SQL is case insensitive. So you can write something like select star from world. Okay, that's fine. That's the same thing as select star from world. They're the same thing. The thing is, in that in literature and in SQL, keywords are all caps by convention. Okay, so by convention, important keywords in the structured query language are generally all caps. There you go. Okay. So this is the general form of the select statement in the structured query language. In this case, the example is, this example uses a where clause to show the population of France. Okay, note that string, this is very important too. Note that strings, pieces of text that are data, should be inside single quotes. This is a very important point. Single quotes is used for strings. Okay, now in this case is selects population from the world where the name is France. In this case, what it's going to do is going to get the population of France from the world table. Okay, so I'm just going to run this. Wrong answer, and just get you the population. Okay, if you don't know what field that you want, you can actually, if you don't know what field to select, you can do a wildcard and asterisk. And now it's just going to return everything, all the fields of France. Okay? You can do where names, you can do this all in one line. Germany. Okay? Still too many columns, but if I just do population, select the population from the world where name is Germany, and it's going to give you, that's the correct answer, to give you the population of Germany. Okay? There's also other keywords that in structured queries, so many of them. One of them is in. The word in allows us to check if an item is in the list. The following below actually shows you the name and population of countries for, Brazil, Russia, India, and China. You can do that. There it is. And show the name and the population for Sweden, Norway, and Denmark. And there you go. Okay, so now you have an understanding of how to query data in a database table, the structured query language. You know that keywords select from and where. Strings are inside single quotes. That's a very important point. So now, okay, let's do an example where things can go wrong, horribly wrong. Now, I'm going to have a database table called users. Users is a very popular name for very common in a lot of database systems. Okay, so I'm going to have this database table will have two columns. Actually, yeah, let's do ID, 3 columns. ID, username, and password. Okay, now, again, very important note. For simplicity matters, don't worry about that the passwords are in plain text. That's not the point. In this case is let's use plain text passwords, okay? But that's not the point. So ID of 1, username is Batman, password is Bruce Wayne. Okay. Username of Catwoman. And that's her password is Selena Kyle. Hello, hack_smarter, hello. You are here. And you are going to be and we'll add another username here. We'll add another username. We'll do SoCal Nilla. Okay. We'll do another one. We'll do Bot Ranger 24. Yeah, let's not speak of it. Randy Newman. Okay, so this is a fictitious database table called users. 5 users, there's 3 columns in the database table, ID, username, password. Okay, so now, let me write, let $username equals user input for username. Let $password equals user input for password. Okay. We'll do results, though in this case, the $username, $passwords are all, and $result are all variables. All variables. Then result equals select ID from users where username equals inside single quote username and password equals inside single quote $password. Okay. I think you can see that. Okay. So now, you know what? There is some cases where you do want to have, you don't want the 80 character limit, you just want this to be out. Okay? I think I can do text.md. Okay. Why is it MDM? Okay, whatever. Doesn't matter. So, let's do an example out. Let $username, let's imagine if someone types in username as hack_smarter. Hack_smarter. Actually, yeah. Hack_smarter. Let password equals I am eval Homer. Now let's plug and chug. Let's play plug and chug. Replace $username with hack_smarter. replace $password with I am eval Homer. Okay? So let's read the SQL statements. Select ID from users in the users table where is username equals hack underscore, you find a username equals hack underscore smarter. Okay, we found one. And the password equals I am eval Homer. And we have a match. All right. And we have a match. And what's going to happen is returns 3. Returns 3. Why? Because we're just trying to we're only getting the ID. All right. So this works. This is good. This is legit. Sounds good. Nice and easy so far. Do another one out. Now let $ username equals Batman, and let $ password equals Robin. All right, plug and chug. Replace $ username with Batman. Replace $ password with with Robin in this case. Here we go. So select ID from users where username equals in single quotes Batman and password equals inside single quote Robin. All right, we have a username Batman in the table, yeah, but do we have a record where the password is Robin? Well, no. First of all, there's no one with the password Robin, and there is no record where the username is Batman and the password is Robin. So what's going to happen is returns no or empty set. Okay? No records found. No records found. All right? Do this all over again. But now let's do another one out. And let's, in this case, do, okay, Spot Ranger 24. I'm going to do another one that's legit. And kebab. Plug and chug, replace $ username with Spot Ranger 24 and replace $$ password with kebab. This is also going to return no result because there is no record where the username is Spot Ranger 24 and the password is kebab. So this is going to return no record. But if instead we did Randy Newman with a capital R and a capital N, fine. That will bring you back ID number 5. But can anyone think of where things can go wrong? Horribly wrong? Where can things go horribly wrong? Think of a username or a password, user input for a username or password that can really, really mess things up. Okay, so count underscore Nilla. What if we did this? Okay, let's do the username is Shaq. And the password is O'Neill, where there is a single quote separating the O and the Neil. Okay? You can also add a single quote to close the output. Okay. The Bobby tables problem. Now let's do this one out. Let's do a plug and chug. Replace $ username with Shaq with capital S. And replace $ password with O'Neill, where there is a single quote separating the O and the N. And here we go. What is this going to return? What this is going to return is, okay, is this legit? Select ID from you, there's nothing wrong with that. Where username equals inside single quote Shaq, that's fine, there's nothing wrong with that. The problem is here. Now, you notice from the user input that there is a single quote that messes up the entire expression, the entire SQL statement. You have a syntax error. This is going to return a syntax error. And the syntax error is because you have a mismatch of single quotes. there got to be an even number of single quotes. But in this case, there is open quote, close quote, and then you have a trailing extraneous single quote. This is going to return a syntax error. Now, let's do this all over again. Start at the beginning. Start at the beginning. Now let's do this. Is there a way that you can enter a username or perhaps a password, or maybe a mixture of both, where you can do the sinister job of just returning all the data in users? What can you do? Now, is there a way where you can make $ results going to be all the IDs? 1, 2, 3, 4, 5? That's the job. The job now for you is to return all IDs in the database table. 1, 2, 3, 4, and 5. Think of one. Can anyone think of anything? The big hint is to use single quotes. Okay, what if we did this? What if we did this? Let $username equals, no, you don't even need a star, not a star. You do need to take advantage of single quotes though. What if we did this? Yeah, that's way too complex. Don't even need that. Don't even need that. Now, the username or the password, in this case it's a lot easier to do it with the password. The password have to use single quotes of some sort. Okay? What if you did this? Let's use the username equals, let $username equals Tony. What if you did this? Blah, single quote, or. Remember, or is also a SQL keyword. Single quote 1, single quote equal single quote 1, closing single quote. Let's do it out. Let's replace $username with Tony. And let's replace the $password with this mess right here. Okay. Select ID from users where username equals single quote Tony, single quote, and password equals blah, a password equals single quote blah, single quote, or single quote 1, single quote equals single quote 1, single quote, single quote. The result is going to be a syntax error. Why do you have a syntax error? The last closing, you have, again, a mismatch of single quotes. Okay? But what if you did this? Let's do this again. What if you had single quote 1, single quote? What if the password is blah, single quote, space, or space, single quote 1, single quote, equals single quote 1, no closing single quote? Yeah, that's exactly what you're supposed to do. Good job, Scomp 116 student. There you go. That's the whole point of lab number 7, which I'll get to in a few moments. Now let's plug and chug. Replace $username with Tony, and replace password with this $password with this mess. Select ID from users where username equals single quote Tony, single quote, and password equals single quote blah, single quote, or single quote 1, single quote equals single quote 1, single quote. Now what is it going to return this time? Well, I can tell you this much. I can tell you right now that this is not going to return a syntax error. There's no syntax error this time. This is fine. So let's evaluate this from left to right. Okay? So really, okay, so here, select ID from users. Okay, that's fair. Where username equals Tony. Do we have a username of Tony in here? Well, no. So that is really what it boils down to. If you want to do a rewrite, where false and password equals blah, well, there's no password equals blah, or true. So let's actually break this down. Select ID from users where, okay, let's evaluate this from left to right. What's false and false? False and false is always going to be Boolean algebra. False and false is always going to be false. Okay, false and true is going to be false as well. But then we have false or true. But what is anything or true? Anything or true is always going to be evaluated to true. So the real short now of this, the short in the select statement is select ID from users where true. Okay. Last time we checked 1 and 1 equals 1 is always going to be 1 is always equal to 1. So, okay, select ID from users where true, well, that's always going to be true, so it really boils down to select ID from users. So what this is going to returns 1, 2, 3, 4, 5. It's going to return all the records in the database. Okay? And it's going to return all the user IDs. All right? God forbid if this was select star from users. All right? Then it's just going to dump everything. ID, username, password, everything. It's going to dump everything. If I did select ID, then it's going to say returns the entire user table. Bam. And this, my friends, is a SQL injection problem. The SQL injection problem is, can you craft a user input that can be sent to a SQL statement and perhaps bring you back well, in this case, can you bring back really undesirable results? Okay? In other words, dump an entire database. Okay? Or have the access to data that you should not have access to. I repeat, for SQL injection, the real power of SQL injection is having access to data that you should not have access to, like all the records. And the culprit is twofold. Number one is the single quote in this case, it's really to say, the single quote in a SQL, in SQL. And number two is the mixture of a computer program, and a SQL statement is a computer program, and user data. All right, you never want to mix the two together to make a computer program. Okay? This is the oldest trick in the book. Okay? SQL injection. The SQL injection has been around for decades. All right? So if you go to CWE Top 25, most dangerous software weaknesses, okay, then 2023 list, numbers 2 and number 3. We talked about cross-site scripting in class on Tuesday, and today is number 3, CWE 89. The improper neutralization of special elements using a SQL command. Okay? And the description is, the product constructs all or part of a SQL command using externally influenced input from an upstream component, but it does not neutralize or incorrectly neutralize a special element that could modify the intended SQL command. when it is sent down. That's too many, that's way too much technical jargon. That's too hard to read. Okay? Really, it boils down to, the developer didn't sanitize the input, didn't actually scrub the input. Okay? And it has all the consequences of the CIA triad, yada, yada, yada. And this is like the oldest trick in the book. CWE 89. Now, CWE 89. How bad is this problem? I'll show you an article. My favorite article of all time. The history of SQL injection, the hack that will never go away. This was written almost a decade ago, and I'll never forget when this was actually written. God bless Vice, okay? One of the hackers suspected. This is written again in 2015. Sadly, it's still a thing up to this day, okay? Talk breach. The method of attack was SQL injection, where hackers typically enter malicious commands in the form of the website to turn out juicy bits of data. It's been used to steal personal details of the World Health Organization employees, grab data from Wall Street Journal, and hit the sites of U.S. federal agencies. Now, again, has anything changed since 2015? The answer is no, and there's been a lot more data breaches since then, and now just, even election databases. It's the most easiest way to hack. Worm said the attack only took a few hours. But for all its simplicity and its effectiveness in siphoning the data, SQL injection is relatively easy to defend. Why is SQL injection still a thing? Well, you have two reasons. Number one, you have legacy systems, and number two is computer science students don't even learn a damn thing about security in their curriculum. So you have the blind lead the blind. Okay, Rainforest Puppy discovered Rainforest Puppy is Jeff Forstall, discovered SQL injection decades ago. Here it is. You already know this. And here it is, over 15 years after it was publicly disclosed. Now it's more like 25. SQL injection repeatedly sits at the number one spot of vulnerabilities on the OWASP Top 10 report. Still kind of is, which is released every 3 years, really 4, by OWASP. SQL injection is always a number one risk. That reflection of just how many incidents there are out there, yada yada yada, by Troy Hunt, who found the site Have I Been Owned. Even worse, some SQL injection are even dumber than you think. Like if you read a news article and the news article has a ID equals 1 and that gives you ID equals 1. And then you get another one with ID equals, then you change it to 2, you get an ID equals 2. Okay, with a SQL injection attack, the attacker changes the ID in the address bar to be something that forces the database to do something that it is not meant to do. Hunt says, such as returning a private piece of data or all the records. Okay? An individual attack may just return one piece of data, a section, but you can repeat it over and over and over and over and over again so that you can get every single piece of data. So, I want to mention while we are here the idea of this tool called SQL Map. SQL Map is a free and open source tool that actually automates SQL injection attacks. Okay, this is going to come in. If you do pen testing like hack_smarter, this comes in really, really handy if you don't want to do SQL injection manually. Okay, it is really easy to use. Okay, actually I got a copy of one out of my machine. CD SQL Map. Okay, it's a Python tool. So you do Python 3. SQL map.py, and this is the latest version. All you need to do is Python 3 SQL map.py -u for the URL, and there you go. We'll play with this a little bit later. Now, for learning purposes, we don't want to resort to tools first. Like, we want to do it the hard way. I don't want you to use SQL Map unless you are for like doing a capture the flag competition or a pen testing engagement. So because tools really saves you a lot of time, so you go from like a 30-minute or 30-hour pain in the ass to a much like shorter than that. Much shorter than that. But let's do SQL injection now without using SQL map. Just use a damn browser. What we're going to do now, before I show you that before we do SQL injection out by hand, Sarah mentioned about Bobby tables, the infamous Bobby tables, XKCD. And here it is. This is obligatory. This is obligatory SQL injection related. This is Bobby table. And here it is. Hello. This is your son's school. We're having some computer problem. Oh dear, did he break something? Did you really name your son Robert, single quote, close paren, semicolon, drop table students? And of course the joke is, oh yes, little Bobby Tables, we call him. Well, we've lost this year's student records. I hope you are happy, and I hope you've learned to sanitize your database inputs. Obligatory SQL injection. Okay, so now let's do a few SQL injection exercises. Now, this is what we're going to do. I have a live instance. I know that hack_smarter is going to be. Can you all hear me? You can all hear, right? All right. I know that this is going to be frowned upon by hack_smarter. Okay. Password, and we're going to do one out. The damn vulnerable web application. I have an instance of the damn vulnerable web application up on an IP address that you can practice and play on. There you go. Let me reset the database for now. Let's clear everything out. We also want to make sure that the security is low. Got that. All right. So now what we're going to do is the SQL injection exercise. Here you go. Enter user ID 1, ID 2, 3, 4. Bring the vulnerability. Dump the entire database. Oh, I'll give you a hint. Go to view source. That's a hint. Dump all the records. Give me all the records back. That is the hint. That's a huge hint right there. The $ query. Actually, we kind of did that earlier anyway. Select first name, last name from users where user_ID equals single quote, $ID single quote. Oops. Dump the entire database table. Let's go. 5. Oh, there is a 5. Look at that. All right. So it's clear that there is no sanitization of $I of the ID. Okay. Anyone think of what you can do? What if I did 1? Do that again. I got 1. But what if I did 1 or 1 space or space single quote 1 single quote, equal, single quote, 1, single quote. What if I did that? What if I did that as a payload? Watch what's going to happen if I do that. Not good. I crashed the page. However, not all is lost. If you can crash a page like this, it is a telltale sign that there is a SQL injection vulnerability. So I repeat, when you get an error, or when you actually crash an entire page, or if you get a 500 error, that is a telltale sign that there is a SQL injection vulnerability. Telltale sign. Back in the ye good old days when systems, they were wonderful. I mean, they would print out the error messages, like right on the screen, like the entire exception. But now, so we have a syntax error. What if we just remove this last trailing single, the single quote? What if we just did that? Ooh, that failed too. Go back. Okay. Oh, we have a, okay, got it. So here's the problem. We do have a mismatch of quote. We do 1 single quote, okay, or single quote 1, single quote equals single quote 1, single quote. We do that. Yep, failed. You know what this is called? Hold on. This is called wrong. This is also wrong. All right, let's do it the right way now. Copy. Bing. The correct way. Okay. You can only, but also some of you folks may have noticed, not only can you do this in the submit box, but you can also do it in the URL bar as well. What if I did ID equals 2? No, ID equals 3. ID equals 1 single quote or single quote 1 equals, well, what if we did that? Oh, you have to have the submit button? Really? Oh, submit equals submit, okay. You can also do this in the URL bar as well. Because as you notice, anything that you type in, it's also reflected in the URL. There you go. Dump the entire database. Just like that. Yeah, and that's SQL injection. Now, for your lab. Your lab, lab number 7, is to break into this website. Okay? Lab 7. There you go. Now, if you've been following this stream, look at it. If you've been just watching this for the last, like, 15, 20 minutes, it should only take you, like, a minute or two to bypass the authentication. Okay? If you're brute forcing this stuff, brute forcing the username and password, you're doing it wrong. If you're spending over 10 minutes, you're doing this lab entirely wrong. This should take literally a minute or two, especially if you've been following what we've been doing. Bypass the authentication, get the phrase that pays. Okay? Also, a very important keynote here, a very important note. There is a phrase that pays. If you get a white screen, or you got a 500 error, that's not good. Not good. Not good at all. You have to get a key. You have to get a key. A phrase that pays. And that's how you know you did the lab. Okay? That's it. That's your lab, folks. So now, let's dump a devoter database, shall we? Yes. So, we have an election, the U.S., the major election coming up in November. In a few weeks, please go out to vote. So, if you go to github.com, go to mshao01. I have a repository called the Vulnerable Voter Database. There it is. A deliberately vulnerable voter database. I built this, 3 years ago. for government, govies, lawmakers, politicians. This is a deliberately vulnerable system. Do not launch it against on a real internet. Do not launch this on a real internet. All right. Do not, please, also, another disclaimer, do not attack your state's actual Find My Voter registration status. Don't do that. There is an instruction for Docker. I believe that it kind of is up right now. But anyway, I put a lot of references. So, for example, yeah. (2016) It's sad. 2016. Is this one good? Yep. SQL injection. There you go. Now I have an instance of this vulnerable voter database here. Ooh, here it is. It's a fake Find My Voter registration status. Now, you do A, B. Now, wait a minute now. Now, find something really messed up here. You have a couple of fields here, name, day, and year, the month, day, and year, and also the zip code are constrained. Zip code, you can only type 5 characters. Submit the query, no results. Wait a minute, let's do a view source of this page. The date of birth month, it's only a certain number of options. Date of birth day, date of birth year, so many different options. And here, the zip code, the max length is 5. Alright? I want to come back to this for a second. We're going to use this, but also in similar vein. If you go back to the damn vulnerable web application, I don't know if you folks remember. If you tried out the cross-site scripting stored exercise, and cross-site scripting to do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, this, here the name field is constrained. The message is also have a certain number of characters as well, too. Yeah, there's a certain number of characters that you can type in. So you may be asking yourself, is there a way that we can bypass these restrictions, bypass the number of characters that we can actually type in into a form? The answer is absolutely yes. Absolutely you can. And we're going to do that right now. Like, if you go back to the fake voter registration, I don't care what the name is. Okay, can I do A or 1 equals 1? Let me just copy this. But I can't do it for the zip code. Because the zip code is 5 characters. If I hit submit a query, I got no results here. This looks like it's of some sort. So let me ask you this. Let me ask you folks a question. Can you describe how the web works? In simple language, how does the web work? I need someone to chime in. How does the web work? Okay, Coram said request response. That's it. Request response, request response. So right now, if I hit sign guest book, the moment I hit the sign guest book button, a request is sent. And the response is this section of the page. What if we did this? So right now, I'm doing a direct HTTP post request. Let's do that. Let me do SoCal Nilla. All right, no request is being made yet. No request is being made yet. I have to check this off. But if I hit the submit query, the moment I hit the submit query, an HTTP post request will be made to 18.191 192.168.105. The request will be sent to that IP address. HTTP post request will be sent to that IP address when I hit the submit query button. And then I get as a response no results from 18.199.188.105. Is hack_smarter still here? Hack_smarter still here? This is where we're going to use our friend in one of our favorite tools. What if we intercept the request? Actually, curl is not going to help either, because curl doesn't absolutely do a direct HTTP request. What if we intercept the request before it is sent to the web server, make any changes that we want, then that gets submitted, we get a response back. The idea is, what if we hit the submit query and our entire HTTP request gets intercepted, doesn't get sent directly to the server yet. We make all the changes in the world that we want to the input, to all the data, even HTTP header fields. Then we submit, and we get a result back. So yes, imagine if there was a middleman that intercepts the request, and we can do whatever we want with it. And that idea is called a proxy, a web proxy. A web proxy is a very important tool in cybersecurity, especially for application security, where you can do all sorts of auditing and tests against web pages, websites, and web applications. Last week, we talked about ZAP. OWASP ZAP, which is free and open source. Okay, you can use ZAP. We can also use Burp. And today, I'm going to use Burp. Burp Suite by Portswigger. Okay? Burp Suite by Portswigger. Why am I using Burp Suite? Go to Products. Go to Burp Suite Community Edition. Okay? Not open source, but the Community Edition is free. And the important thing that comes with the Community Edition is a proxy. Start your web security testing journey now. Yada, yada, yada. Okay. You can try it. Okay. Okay. The Burp Suite Community Edition. HTTP, HTTPS, web proxy, and history tool. This could be really interesting for you down the road. It also have a repeater, a decoder, a sequencer, and a comparator. You can do repeated HTTP requests. You can even do brute forcing of HTTP forms and an intruder. Okay? So, Burp is platform independent. It's written in Java. Okay? And you can just choose your platform. Go to Burp Suite Community Edition. And this is what happens when you load up. Welcome to Burp Suite Community Edition. Okay, this is good. Hit next. Just use the defaults. This looks good. And what we're going to use is the proxy. Go to the proxy tab. And you can see right now it says, if you turn intercept on, messages between Burp browser and your target servers are held here. This enables you to analyze and modify those messages before you forward them. What we're going to do now is we're going to open up the web browser that comes with Burp Suite. And believe me, this is just awesome. Back in the days, Burp did not come with a browser. And you had to either configure your system or you basically have to use Firefox and do configuration there to talk with Burp. Burp, how it works under the hood is a server. All right, that works on, it's a server that is running. All right. Now, if I'm going to open the browser, here it is. And the browser, which is awesome, is Chromium. It's Google Chrome without the Chrome branding. All right. So anything that you do, if you turn Intercept on, anything that you do on the Burp browser will be shown here. I'm going to move that here. All right, I can enlarge the window. That's fine. We can afford that. I got some screen space here. But now I want to go to. I need a copy of the URL. All right. Let's go to the fake Find My Voter database. And I got the Intercept screen here for Burp. And I'm going to open my browser in Chromium. And now I'm going to hit the Enter key. There you go. Now I'm just going to do a straight, SoCal Nilla. Date of birth is February 1, 2001, 0000. Check the box, hit submit, no result, so it works. Now I'm going to do Intercept on. Intercept is now on in Burp. Messages between Burp browser and your target servers are held here. This enables you to analyze and modify these messages before you forward them to the server. Okay, now let's do that again. Let's go SoCal Nilla, January 5th, 1992. Zip code is, let's do something dumb like 01234. Check the box. Watch what happens now when I try to do the HTTP post request by hitting the submit button. Boom. Here we go. Now, I haven't used Burp for a while, and there is a new screen. You can now see, now one of the things I don't like, and I'm going to go to settings. I want to go to user interface, display. I'm going to use a font of 18. Yeah. So you can have a bigger font. No. Damn, I want this to be 18. Okay, 8. No. Proxy settings. Display. Okay. Damn. Yeah. I want it. Okay, I guess not. Is there a way I can increase the font size here? Nope. Nope. Here. I guess I can't increase the font. But you notice, you see the HTTP request header? This entire thing is the HTTP request header. This is the HTTP request data. Okay? So yes, you can see now the HTTP headers, the entire HTTP request. The body and the header. And in fact, look at the breakdown. request attributes, request body parameters, request header and request body. Look at that. Everything I mentioned, all the key value pairs. And of course, what can you do? Can you modify anything? Of course you can. Now, we're not going to do any modification yet. Let's forward the request. And now notice there's like no results. Let's do this again now, but this time we are going to modify the request. Let's do A. Submit. There it is. What do you think we're going to do? You have two options to change. You can change it directly here. You can do, let's say, A, single quote, space, or space, single quote, 1, single quote, equals single quote, 1. We're going to do SQL injection on the zip code. In fact, there is a way to actually break the voter database. So now the zip code is, now you notice two important things. The zip code is longer, it's first of all, it's a SQL injection payload, but the most important thing is, you notice that I completely bypass the 5-character limit on zip code. So of course, the SQL injection payload is longer than 5 characters. This is what you can do with Burp. Or a web proxy, a good web proxy. Now you forward the request. Watch what happens. Boom. There you go. I think there's at least 10,000 voter registration records here, all fictitious. Dumped. Dumped. This is how bad SQL injection is. Yep. This is how bad SQL injection is. Now, there is something that people have complained all the time. Like, why in the world do I want to use Burp? Because you know what I can do? I can just file save as the HTML page, remove the character limit of 5 characters on the zip code, and just use that. Okay, you can do that. You can get away with doing that. But the problem is, the biggest difference is, you know, doing that versus Burp. One of the nice things that you can do with Burp is it gives you an entire history, okay, of all the HTTP method. Yeah, you can see that. You can build a nice sitemap of like whatever you're investigating or whatever you're doing. So a good example is, another good example we'll use is, let's go back to damn vulnerable web application, and you notice that the proxy got intercepted, I'm going to forward you can forward the request, forward the request, forward the request, keep forwarding, and here you go, admin, password, boom. Okay, you can see how things work under the hood. You can see the entire, you know, one of the things that you can't do, like, well, you can do this, but not as nice using web developer tools. You can see the entire HTTP request headers and modify any request header. There are I mean, we've seen cases where there are vulnerabilities with certain, modifying certain HTTP request headers. Forward that, forward, keep forwarding, keep forwarding. Okay. Never saved the password. Now you go to cross-site scripting stored, forward. Oh man, some idiot decided to actually change the security, yep, forward. Someone changed the security to, yeah, it was low originally. Let's use low. There you go. Anything that you do, any HTTP request that you do, gets intercepted by Burp. Yeah, forward, forward. There you go. But now if you go to cross-site scripting stored, now you go to forward, keep forwarding. So now, remember how we did A, B, C, D, E, F, G, H, I, J, K, L, you know, and then we say hello. So there's a long message there. Sign the guest book. Now what you can do is this. You can actually bypass the character limit and say hack_smarter, and then I'll do a script tag, you know, alert. cross-site scripting. This is way over, 10, 15 characters. Okay. Hello, all you happy people. Okay. So now what I'm gonna do is record the request and notice what happens. Yep, there you go. That's a nice thing about using a proxy tool, in that you can actually build a nice sitemap. Okay, you can build a nice sitemap of your target that you're that you're trying to analyze. A really good example, what is also really cool, because now that there is a built-in browser for burp, you go to facebook.com. Go to facebook.com, allow burp, yeah, of course. Now the intercept, you can see how Facebook works under the hood. All the fields, keep forwarding, and you're going to do a lot of forwarding. There's so much stuff that happens under the hood. So much stuff. Oh, it's not even done. Like, you're going to get so much crap. Okay? HTTP history, socket history, the target. This is cool. This is where you can build a sitemap. You can see a sitemap, all the folders of Facebook. Look at that. Ajax, there's a fundraiser? What's that? Let me go to this browser right here. Facebook.com/fundraiser. I didn't know that. Yeah, fundraisers. Fundraisers, games, groups. Oh yeah. Policies. What's R? What in the world is this R.php? Can I see what that is? No, you can. That's R.php settings. Yeah. Boating Information Center. Oh yeah. All right. Request in browser in the original. Yeah, sure. This is cool. Damn, there's a lot of stuff that happened. Interesting. I don't know what R is. Oh yeah, you can see so much stuff under the hood in Facebook. Okay, ad campaign, all activities. What's that? So much stuff. So of course, this is one of the nice big benefits of using a web proxy like burp. Now I'm gonna quit. I don't need burp anymore. Okay. One of the things I do want to show you is, since we're talking about burp and Portswigger, who makes burp, has something called Web Security Academy. Here it is. So if you want to learn more about SQL injection, web vulnerabilities, this is all free, all for you. It's free online web training from the creators of burp. Material. So much you can learn. Web LLM attack, API testing, NoSQL injection. Hey, NoSQL injection, I want to give a shout out to Russell Butterini. All right. Yeah, Russell and I wrote actually I didn't write it. Russell wrote a NoSQL map back in the ye good old days. I gotta text him after this thing. Yeah, NoSQL map, but basically it was a play on SQL map. So I misspoke. No, Russell wrote this. Yeah, one of our claim to fame. So give a shout out to Russell. But here it is. Originally authored by Russell at TCS Tools. Now, yeah. Yep, SQL map and the concept are based on the intention of my presentation at DEF CON 21 on abusing NoSQL databases. That brings a tear to my eyes. And here it is, like things like SQL injection. Yep. What is SQL injection? Yeah, free training. Good training, too. Yeah, good training. All the content. So with the time that we have left, we have one very important thing left, which is how do you defend against cross-site scripting? Well, that, and also SQL injection. How do you defend against SQL injection? How you defend against SQL injection is very much like how you defend against cross-site scripting. Sanitize user input. Sanitize user input. But for SQL injection, what you need to do is for your if you're writing SQL code like database code, like web applications that interact with databases, you need to use prepared statements. Prepared statements. Okay? So here's what prepared statements are. Okay, what a prepared statements are, it separates out the user input from the actual computer program, which is the SQL statements. So how you defend against SQL injection, well, it's really twofold. Again, number one, big idea is really sanitize user input. Prepared statements are resilient against SQL injection attacks because what it is parameter binding. Okay, the idea of SQL injection is parameter binding because parameter values which transmitted later during the protocol needs not to be correctly escaped. So here is basically how prepared statements work. The idea is very simple. The query and the data are sent to the database server separately. That is all. Okay? The query is a computer program. That is sent first. Then the second thing is the data. Okay? The root of the SQL injection problem is mixing in of code or a computer program and user input data. SQL queries are actually legitimate computer programs, and as we are such, creating program dynamically, adding some data on the fly. So here's an example, and you've seen this example before. We've done this today. $expected underscore data equals 1, $query will produce the query, here we go, plug and chug. While this code with spoiled underscore data, which is the user input, you mix it with the query, will produce a malicious sequence. Okay? Now here's how prepared statements work. Every single computer programming language now support prepared statement. So there is no excuse to not use prepared statements. Like this is PHP. So now, using prepared statements, the first thing that you do is prepare the program, or that's why they call it prepared statements. Okay, so prepare. Now you notice that user input, anything that is going to depend on user input, is now you're going to use a placeholder, question mark, where the data is substituted by a variable called a parameter or a placeholder. Note that this exact same query is sent to the server without any data in it. And then we are sending the data with a second request, essentially separating from the query itself. Okay, so you do a execute the statement, and $data is just whatever the user inputs are. Whatever is in $data is going to replace the stuff in the question mark. So at the end of the day, it can't alter our program and do any harm. That's it. Quite simple. And that's it. And there's no excuse to not use prepared statements. And that, folks, it's SQL injection. And now it's happy hacking time. Okay? So now you can bypass authentication in that lab that I have. All right, folks. Take care. Yes. That is all for today.